Dobra, to zaczynamy w takim razie, tak? Tylko ewentualnie jeszcze wyślę.
Ale siedzą, czekają w... Ale to wideo mi się włączy i transmisja wideo rozpocznie się w końcu.
No bo transmisja wideo rozpoczęła się właśnie teraz, jak kliknąłem rozpocznij transmisję. Widzicie, teraz jest zatrzymaj transmisję. Transmisja wideo się rozpoczęła. Wysłałem tam do Patryka Kubiaka link.
No.
O, cześć Patryk.
Wiesz co, no jestem, no hej.
Udzielisz tam komuś, czy jesteś sam?
No mogę spodzielić, wiesz co, a może na tej stronie swojej to wrzucisz też? Tam widzę, że z Warszawy są ludzie też. Ja tylko w Poznaniu mogę spodzielić. Bo wiesz co, ten link co dałeś to jest do wideo chyba i tam nic się nie dzieje.
Ja się już dzieje, bo jesteś na żywo, jesteś już na YouTubie, dobra.
Dobra, to jest tam, to ja już sobie zostanę na hangoucie, nie?
Sobie zostań, to już się tylko wycisz i jedziemy.
Dobra.
Dobra. To zaczniemy może od tego, jakie macie doświadczenie z SVN-em względem GITa. Kto więcej używał SVN-a, kto GITa. W rękę, kto więcej SVN-a. Yeah? Should I please speak English? Will it be okay with everyone else if I speak English? Okay. So who has more experience with SVN? Like most of the people, right? So there is a nice phrase here. Where was it? Let me enhance this font size for you. Well, it's not what I've written, so you'll need a little bit of re-education, okay? Because Git is different, and that's what you know from Subversion will mostly not work as you would expect it to work in Git, and that's a good thing. You will hopefully don't be put off by the differences. You will have to start thinking a little bit different, but believe me, when you start using Git, you will never want to go back to SVN. That's one of the things that you don't go back to when you start using Git. So let's, first of all, what you see here is actually a Mercurial tutorial. And anyone knows what Mercurial is? So it's a kind of Git from Atlassian. It's a bit more kind of user-friendly. It's, I think, it's easier to learn, but follows the same principle as Git, right? So if you learn using Mercurial, you essentially learn the same principle that Git uses. It's just a difference of a few syntax. A syntax of commands is a bit different in a few places, and the default behavior of both tools is a bit different in a few places. But in general, they are very good at what they do, both of them. And Mercurial is, well, as I said, probably a bit easier to start with when you're moving from SVN. And there is a very good page of introduction to Mercurial that you can very well follow to understand how Git works. And so it's called hge.com. I recommend you go there and try it out later on.
Darek, do you share your screen, because we cannot see anything?
That's a good point. So there's this page for the people watching. HGE. Thanks, Patrick, for a reminder. And what I was actually saying, first chapter of this tutorial is Subversion re-education, right? So let's go through a few popular beliefs when coming from SVN. So there is a belief that we have to keep the repository on a central server, so it will be safe, right? It's there. It's a big server, and it's safe there, and nothing can happen, right? Because it's awesome. It's enterprise server. It has all those certificates, and it will always work. It will be always available for everyone. Yeah, you know that thing, internet? It breaks too, right? And the server is the same machine as every other machine, right? So it's as safe as on your laptop, basically. It's nothing safer that it's on a different machine. It can, I mean, it can have some failover, some more security measures, right? But it's still in one single place, and someone can, basically, when you break this one place, you're doomed. You don't have your source code, right? So in distributed systems like Git, the full source code with the full repository, with the whole history of the repository, is on every laptop of every developer. So when I'm using Git, I have exactly the same what is on the remote server usually. And my colleague that's sitting next to me has also the whole repository. You would think, oh my gosh, that's got to be a lot of space, right? How big hard drives you use for that? Well, first of all, it's not a lot of space because we don't commit binary stuff to repositories, right? We commit source code. Those are text documents. Text doesn't take up much space, and you have to consider compression also, right? The things are compressed in Git, so it's really not the case of space. And if it were, how expensive disk space is nowadays, right? It's not the most expensive thing when you come to think about it. So it's actually safer, right, to use Git than a distributed system in general. And the second popular belief is, well, it makes branching too easy, and branches cause problems, right? Because branching is a branch, that's something hard. You will have merge conflicts, and everything will be messed up when you create branches, right? Do you have the same belief when coming from SVN that branching is hard? Do you do branches in SVN? Do you know what a branch is? Or is it a forbidden fruit that you don't? You were told one day that don't do it. So how is it?
Sometimes yes.
Sometimes. And how is your experience with branches? Don't do it. Well, that's the same experience that I had when you start creating one.
I mean not in Git. I mean
in SVN, right?
Yes.
SVN. When you create a branch, then a second one, and so on. Well, the strategy that SVN uses for remembering the repository history is one of that it remembers the state of the repository in a given revision, right? So it remembers that in this revision, this file was exactly like this. And then you create a branch, and you change a file, and the file has different state, right? And your colleague creates another branch and changes the same file, and then the same file has a different state. And then when you merge, the SVN ends up with two files under the same path, but two different files. And it doesn't know what to do with them. They are different, and that's a conflict. Right? So Git and Mercurial use different strategy for remembering the history. In Git and SVN, the history is kept as in change sets, not in revision. A change set is a set of differences between one revision and the other. So it's a way to go from one state of that is one revision, right, and to the other. It's the difference that is between them. It's not the one state and the other. It's what's different between them. So it's a kind of what step should I do to go to the next change set, right? To the next state, to the next state in the next revision, kind of, right? Kind of revision doesn't really exist. It's a change set. It's a step that you take, right? For example, you refactor a function, right? You move a function, right? And those are steps that Git is able to remember. And thanks to that, even if, for example, you change something on one branch in a file, and then someone else moves this file somewhere else, right? Git can see, okay, you changed something in the file, and you moved this file, so Git is able to merge those two changes without conflicts. Whereas Subversion would see, okay, someone did. I have a file here that has this state, okay, but in here it's deleted, and there I have a new file there, and in here it doesn't exist, right? So we'll end up with basically two files in two different places in SVN, right? That's more or less the difference between those two approaches, right? Any questions to what I just said? Okay, so branching is easier in Git, much easier. Merging is much easier. Conflict resolution is much better, and that's a good thing, because you should be able to use branches. They were meant to be used, right? In general, it was a tool that was not too well implemented in SVN, and that's why it was hard to use, right? It is much better implemented in Git, and you should use branches, right? So don't be afraid of branching in Git. And the last misconception is that it's basically hard, right? Because well, you've got, well, I use Git from the console, right? I don't know how about you, but I don't need anything else. That's my whole Git interface, the console, right? And it tells me everything. For some people, it's hard. I mean, you don't have to use console. There is lots of visual tools that you may use, and that's fine. I will teach you how to use Git from console, hopefully, because this is really easy. In contrast, what you might think at the moment. And believe me, you can use SVN from console, and it's also easy. Within the scope, of course, what SVN can do, right? So that's where this sentence came from. Is actually the guy that was trying to learn Mercurial asked the other guy that knew Mercurial to list out all the differences in some sheet, right? To do the listing and see how, when I do this in Subversion, how do I do this in Mercurial, right? Or in Git, right? That's not exactly a good idea, right? As I said, they have a different approach to certain things, and well, you have. It's a version control tool, one of them, and the other is also a version control tool. But you have to start forget a bit how you used SVN as a version control tool, and try to learn from the scratch how to use a distributed version control tool. Okay, it's not like straightforward. I did this in SVN, and that's how it works on Git. It's not always the best idea to think like this about this migration. Okay. Yeah, and one of the reasons was how the change sets are, right? What's the difference between revision and change set? This is here explained by an example of addressing system. I don't know if you ever had a pleasure of writing an application for some Eastern market, right? China or Japan or Korea or this kind of neighborhood. If you ever had an issue to design an entity to hold a customer address in this region. You would thought, well, what's the problem with addressing, right? There is a street and street's name, and there is a building and the building number, right? Well, that's not how it is around the world. Not everywhere that's how it is. Yeah, believe me, that's not like. For example, here is Japan. Like the streets don't have names. Basically, only very important streets have names. Just blocks, right? The neighborhood has a number or something, or it's kind of like it's different. It's not like the street name and the building name. No. Just the blocks are numbered, and in Korea, for example, there is like also even different. Like there is this neighborhood is named, and there is an address that is like the third building after the second turn left, and on the third floor, or something like this. Like this kind of descriptive address, kind of, right? The local people, that's normal for them, right? But when you come a different neighborhood, you are basically lost and you cannot find anything there. Right? Okay, that's maybe enough as an introduction, kind of the differences in kind of general way. Let's now try to forget about SVN. And I will allow for one more chance to ask a question about SVN and the differences, if you have any. If not, we will go to proper Git. No? Okay. We'll start by creating just. I thought I will just create a repository on GitHub, and we'll just try to use it, right? I don't know. Git workshop IMPAQ. Yeah, okay. Create. Yay, so now we have a repository. Oh, well, you technically don't need a GitHub account for that, but it might be useful if you have one. So I mean, if it's easy to register, you can use your social network account on Google Plus or whatever to register. You can do it right now if you can. Find this. Find me there, right? github.com/Kaczyński, and you will find this repository there, right? So basically, at the moment, it's an empty repository. It's nothing there. I just created one. It's like same as you would go to, I don't know, our local GitLab, right, at IMPAQ. And you would create a repository, you would have an empty repository there. Right? It's nothing there. There's just an URL. I mean, you can use this without a GitHub account using HTTPS, right? You can just maybe. Right now it's nothing there, so I will first maybe create something. Well, workspace IMPAQ. Here, Git workshop. Okay. So. Okay. That's what I wanted to do. I want to do this. Yeah. I will be using SSH because I have an account. I have an SSH key. What's this? Failed to push some refs. Commit, okay, whatever. So now when I refresh this, yeah, it will show an actual repository is right now created, because what I created previously was just a placeholder for the repository. Actually, I did create a proper repository with this command, git init. And I don't know if I haven't broken it now. No, it seems to be working. That's okay. But to create a new Git repository, actually what you do is you go to your local computer, you create a directory, and you type in git init. And what it will do, it will just create a subdirectory called .git, called .git, and this .git directory is the actual repository. Everything that you have in the repository is in this very directory, right? So when we go there, there is this, this one is important, there is like branches, objects, references, heads, everything, all the configuration, everything is here, right? So when you pull, this directory gets updated first, right? And this is the state of the whole repository. You always, as I said, you always have it on your computer. Everyone has it, right? So where is this on here? Issues, pulls, settings. Oh, there it is. SSH. Okay, so let's now try everyone to clone this repository to your local machine. Okay, so when you go to this repository, down here at the bottom you can choose SSH if you used Git or have GitHub configured, or at least have no SSH or have SSH key. Who uses SSH basically and has an SSH key and knows what it is? Okay, so I encourage you to read about it and start using it if you don't already. Okay, I mean that's a bit out of the scope. You can use Git with HTTPS protocol instead of SSH, and it will work just as well. Just you will have to type your username and password constantly, so that's your pain. With SSH key you don't have to. You have an SSH key that basically authenticates you, right? So that's even more secure than username and password. There is a good tutorial of how to configure SSH on GitHub, so just Google it. I won't be going into details. So for those who don't have SSH, you just take this SSH HTTPS link here and just do git. Go somewhere to your machine, git clone, and let's call it HTTPS copy of Git'em workshop IMPAQ, right? Yeah, and since it's a public repository, you actually don't really even have to authenticate to download the changes. You would have to authenticate to push the changes, right? To actually make the changes to the remote repository. But you can download it without authentication. Git clone, you just type git clone and copy the URL from here, right? You can add the name of the folder at the end, but you don't have to. That's optional. By default, it will create a folder named Git Workshop IMPAQ. I added the name because I already have a folder Git Workshop IMPAQ. Okay. So it's git clone the URL of the repository and the folder where the repository should be cloned into. Okay. which the last one is optional. By default, it will create a folder named exactly like this. The last part of the basically the repository name will be the name of the folder by default. Okay. Who was able to clone the repository on his local machine? Everyone? What's the problem? blame whatever operating system you use.
Na belce kliknij. Paste.
There you go.
Not page, paste.
Paste.
There you go.
Right?
Myślę, że nie zablokować.
No, I mean, you can use HTTPS. You can use HTTPS, but if you have a GitHub account, you can go to your account and configure SSH key for your account, right? And use your account to clone this repository because it's a public repository, right? I mean, you will require a GitHub account to push changes, and I would like at least some of you to push changes to this repository during this workshop. So in the meantime, if you have already cloned this and someone else is still cloning, please make sure that you have a GitHub account. I might have said, I should have said it earlier maybe, but it should be easy to create one. Okay? When you have this repository, okay, guys. One thing: when you have this repository cloned, issue this command and see if the output of the command is the same for you as it is on the screen. Git log. In the repository folder.
Aha, i na co się do repository przydostać?
Yes, go into the folder that you created, that Git created, and issue the command there.
Jaka jest ścieżka standardowa?
No właśnie.
The default path is the name of the repository.
Okay, but I can make... Mogę też robić szybki dostęp, że piszę i od razu nazwa repozytorium przeskoczy, czy muszę dać całą ścieżkę C, dwukropek, ciach.
No, wherever you are when you issue the command, right, it will create a subdirectory in the place where you are.
Okay.
Right?
Okay.
So I was here, right? I was in this directory, and I issued this command. Where is it? This one, right?
Yeah.
And it has created this directory in here. Yeah, it creates a subdirectory.
To go inside and
Yes, yes. Go inside, right?
Okay.
Everyone has it?
Okay.
Okay.
It's okay?
Yeah, that's okay. No, it's not empty. It has one directory
Okay,
named
but I don't
.git.
see it's
I mean, you
G,
show hidden files or something, right?
It's directory.
One.
One.
And it has one directory called .git.
I don't have it.
You have it. It's hidden. If you can issue git log and it tells you exactly this, then you must have the directory. Otherwise, it wouldn't work.
IMPAQ. Okay, there is auto. Yeah, auto. I think it's true.
It's hidden by default, right? Okay. So right away, what git log does? Git log shows you the history of the repository. Nothing much happened in this repository, right? Just one commit. When I have another repository that I have lots of commits, you will see, well, that's a lot of changes, right? Do you? Yeah, that's what I was supposed to. Do you think this, what I'm looking at now, it's useful for finding something in the history? I went to one of my projects and issued the same command, git log, right? But this project actually has a history, right? That is quite long. I can scroll and scroll and scroll and do other way around. Well, you can try finding something there, but I prefer something like this, for example. For you, it might be at the moment maybe less. Well, at least for me, that's kind of more. It tells me more because at least it tells me a history of everything basically in the repository that's happening recently, not only on my branch and on the other, but maybe we'll get to branches. You can also use this. Oh, that's maybe better. That's maybe better. I was doing something, Lasia was doing something here, right? And some other people were doing something here. You can see what is actually useful is on the left side, right? That's a tree. Right? You see the lines? Those are branches. Different branches that were created and then were merged, and then they had different history, right? And so when you have a repository that has a lot of branches, a single list is not enough to present the history of the repository, right? What you need is a tree, right? So this kind of view. There is also lots of visual tools for that. You don't have to use the console. I do. And to help with that, there is a project. And that's the name. That I recommend you use in conjunction with Git, right? But before we go there, I forgot about one thing. Basically, apart from having Git installed, it is good to have one more file on your local computer. It's a global configuration of Git, right? And in this global configuration, you will need a few things. First of all, the file with the global configuration is in your home directory, user home directory, and it is called .git-config. Right? Even on Windows, that's what it is, right? This is your home, right? So it's like /c // users / your username, and there is a file .git-config. Okay. So if you don't have this file, create it. Okay. Yeah, create just an empty text file named .gitconfig. Mine is quite full. Hopefully yours will be also. The minimum what you should have there is this kind of information, right? It's a regular ini type file, right? So you know, Windows ini stuff, right? That's good enough. That's very good. That's already great. Your email should be the one that you used on GitHub to register, right? For the need of this workshop. I use this everywhere, right? And actually, the rest of all those things what I have here below, it's coming from here, right? So we can just copy paste the contents of this file into your .gitconfig, and you'll have everything that is here. So the manual is in Polish. There's lots of useful kind of aliases, right? Because in Git you can declare aliases for commands, and you can see there's lots of aliases defined here, right? Like any changes, changelog, and so on, right? One useful is Git branches, right? It shows you all the branches that are currently in the repository, not only because by default you have Git branch, right? And it shows you the current branch. There is some branch -a or something like this, but you can just use simpler alias Git branches, right? And it shows you not only what branches there are, but the revision of each branch, where the change set at which each branch is, and lots of useful information, local branches, remote branches, and so on. We'll get there. So if you don't know this, I recommend. It makes life with Git easier. It has a lot of useful aliases. Just read through this and see what it will return for your project repository. Hopefully you have one, or you don't, do you? Okay. So that's configuration. Everyone has this git-config file already, right? Name and email? Yes? At least that's this. Let's see, can I? No. Settings. I don't want this, I don't want this. Okay. Okay, can anyone send or tell me their GitHub username so that I can add them to the repository collaborators?
You can add me. Wait, I check my email. I don't remember now.
Username or full name?
You can add me, Darek. K Patrick.
Hangout. Paste it. Okay. or whatever, I don't know. One, who can send me messages? That's anyone else? Let's still a few people more I need. This one?
Maybe this one.
When you log in, do you have this picture here?
Yeah.
Yeah, that's this one?
Definitely not my face.
Yeah. From someone from there? Get an account?
Yeah, I have an account. It's Charles. Yeah, but it's not in English, in Polish.
This one?
No, that's for sure.
Then how do you spell it?
Yeah, but you did write it correctly. Try to type Karol Polski. Polski with E. No, none of it.
Nope. Can you show me this?
Yeah, sure, that's fine. Can you sign in? Yep. Oh, really? That is you. Yeah, that's my new offense. Okay,
That was you.
Sorry for the mistake.
Come on. A few more. That's.
Can you add me, Darek? I will send you on chat.
Yes, please do. If you're watching, you can put your GitHub name on the event comments, so I will add you there as well. Yeah, best to put it here. So I will add you. The repository.
I put in the chat window.
That's okay. Okay. Someone else has an account? Guys, come on. Okay, the second useful command is git status. Right? It shows you what is currently the state of the repository. So currently we are on the branch master, and everything is up to date. So the remote repository. So right now we have this remote repository, right, that is on GitHub, and we have a local repository that we have on our machine, right? And everyone has basically the same situation. You have a copy of the remote repository, and that's the most, I guess, common way of working with Git. It's kind of similar as with SVN, right? But not entirely. I mean, in SVN you also had this central server, but the whole repository was only there. You were checking out only, for example, trunk, right? And you had only trunk version of the repository at the moment, or only given revision even of the trunk version, right? And in here you have the full repository, everything. You can switch between branches, you can switch between revisions, view the full history, you have everything locally, right? The full copy. So status shows us that we are on branch master, and origin master is the name of the remote branch, right? Because you have to remember that you have because you have two copies of the repository, you have to remember that you have local branches that are in your repository and remote branches which are in the remote repository, right? Usually there is a set of identically named branches on both sides, right? So you will have a default kind of branch name is master, right? It's the main kind of a, no, I won't compare it to SVN. There is no such thing as default branch in SVN. So you have the branch named master locally. I have a branch named master, and on the remote repository there is also a branch named master, right? So when I have cloned the repository, master is set as a default branch, and the repository was cloned, and my local branch master was created, and it was set to follow the remote branch master as an upstream branch, right? So whatever changes in the upstream branch, in the remote branch, will be reflected on my local branch. So that's why it says it is up to date, because the remote branch is currently on the same place, in the same place as my local branch. It's on the first revision, right? No differences here. Okay, and nothing to commit. Working directory is clean. I didn't do any changes, right, to the repository. Okay, let's add a file, right? A good practice is to add a README file. And even better practice is to write your README files in Markdown, hence the MD extension. Okay, I have created a file. Now I have a directory and an empty file. And how this changes my Git status? Well, the output is different, right? So I'm still on branch master, nothing. I'm up to date with the remote. My local copy of my of the repository is still the same. Nothing has changed in the repository itself, but my workspace has changed, right? I have one untracked file. Untracked means it's not under version control, right? It's the same concept as in SVN. By default, when you create a file, it's not tracked, right? It's not under version control. You have to specifically say to SVN or Git or any other tool that you would like this file to be under version control from now and to be added to a repository, right? And look at that. Git is very helpful here, right? And it says nothing added to commit, but untracked files present. So Git noticed, oh well, you have new files. Well, look, you can use this command called git add to track this file, right? So that's what we're gonna do. We'll add this README to be tracked, right? Now when I issue git status, well, the output is again changed. I'm still on branch master. Remote is still up to date, but I have changes to be committed. And well, here is another hint. Use git reset head file to unstage. But what the hell means unstage? No. I mean, in this specific case, yes, because this file is not tracked. But what does git add do? Git add doesn't add to the repository. It adds to the staging area. The staging area is it's not actually an area. It's just how to call it? No, it's just kind of a list of changes that you did and would like to create a change set out of them, right, would like to commit, would like to add to repository, right? So
should we create this file as on our machine, or we should synchronize with your...
well, maybe let me first create a file, and we'll later go with conflicts, right? Because if I create a file and you create a file, we'll get a conflict, and we'll get there, okay? I mean, you can do it, but until you push it, that's okay, right? You can still roll back. I mean, we can go through this case also, right? So that's fine. I mean, maybe later I let one of you commit the file instead of me, and I will resolve the conflict. Okay? Did you push it? No.
No, I did not.
So don't. Okay. Anyway, I mean, you can do whatever in this repository. I'm quite convinced I can resolve whatever conflict you create. Yeah, I'm quite convinced I can merge everything with everything that you can create. Staging, right? We were on staging. So let's say, okay, but I don't want to add to the repository an empty file, right? Let's write something in the file. And this, let's make it, this will be a readme description of the repository. So we'll say that this is a repository for.
Could you explain us the command you just put in?
It's a text editor.
I mean,
I mean, you can use whatever you want. It's just a text editor. It's not a part of the course, okay? This is a repository for Git workshop at IMPAQ. Okay, and let's save it. Okay, we've changed the file. We have added it to the stage area, right? So let's check the Git status. Oh, what's that? The file is added to the staging, but the file is added to the staging when it was empty. So in the staging area, the file is still empty. When you would commit at this moment, you would still commit an empty file, right? Remember, Git remembers the changes that you did. So you told Git that you added an empty file, right? And then you did another change. You edited the file, right? You changed the file itself. It has content now, but you didn't tell Git yet that you would like to add this change to the repository still, right? So by default, Git will not add anything you do in the repository into the history of the repository itself. Yeah? You have to specifically state that you would like this change to be added. And whichever edit you do, whatever you do, right? By default, it is not tracked by Git. It will show up in the status, right? You have to remember that's an important difference. It's an important difference between Git and Mercurial, because Mercurial has a completely different policy. Mercurial by default will add things you have changed to the staging area, right? Git does not, right? So you have to say. So now what I should do? I mean, I would like to not add an empty file. I would like to add the changed file. So what I do again git add readme, right? Now git status shows only that I created a new file, and okay, git. I'll do it. Let me quickly go back to Oh. Yeah, let me MV. Let me. Don't look at what I'm doing now. I wanted to show you one thing, but I issued one command too much, and I want to go back to a state that we had previously. Okay, so I'm back to a state where I have this file added to staging empty, right? And then a change done locally. I issued previously git add to merge those changes, but I wanted to show git if okay, so there is a useful command to tell you what has changed with more details, right? Because now you see new file was created and the file was modified. So there is git if that show me differences in detail, right? So let's first see the differences that are recorded in the staging area. So for that I am adding -- cached, right? So this is telling me that basically this new file, well, new file created and that's it, it's empty. Okay, and what are the changes that are not committed, right, not added to the staging area? So I'll just do git diff but without the flag, and will tell me that in this file readme I have added 2 lines, one with the sentence and one empty line. Okay, and now when I have git status and add my my most recent changes in this file. So you have to treat git add as not as a command that adds a file to the repository, but this is a command that adds a change into the repository. So git add means add changes that I did in this file into the repository, right? Not add the file, but add changes that I did in this file, right? So now I'm saying add those changes, and yeah.
Command has 2 meanings. Yes?
No, it has one meaning, right? Creating a file is a change in this file,
Okay.
right? Like a single element is a specific example of a one element list, right? That is the same logic, right? That's why I'm saying don't think about git add as adding a file. Think of it as adding a change in a file to the repository, right? And now you can see as the change set that is created from those 2 changes is different, right? We have not only created a new file, but we also added the content for this file, right? As a one change, already added the content added a file with some content. Okay. So we are ready to commit, actually, right? Yeah, question. The question is, could I roll back to the previous state? Not from this state. I mean, you can remove all the changes to a single file or a group of files from the stage area and roll them back to your workspace, kind of, right? But you cannot, when you did a few changes in a row and issued git add several times, all those changes are merged into one change, right, at the moment. So I cannot easily go back to the state where I have an empty file in the staging area and the content of the file in my workspace. That's why I had to do this magic of copying the file and recreating basically the steps that I did, right?
Or perhaps using git stash.
We'll get there.
You can stash.
Yeah, we'll get there. We'll get there. Okay.
Okay.
In general, when you do several changes to a file, right, and you add it several times, the changes get merged into one change, and you cannot then divide it again, right? You have to, if you commit each change separately as a separate change set, then yes, then they are kept as separate change set, and you can then merge them and arrange them differently and remove one from the middle, for example, if you need it. But I mean, adding constantly the same file to the stage area merges combines the changes into one change, right? Does this answer your question? Yeah, okay. So we are ready to commit. And if you remember from SVN, committing in SVN is going to the remote repository and saying, hey, I have this new state of the repository, and here is the new state of this file, and go and have it, right? There you go. In Git, as your repository is kept locally, your commits are also done locally, right? So what you commit command changes only your local copy of the repository. It does not change the remote repository at all. Nothing changes. No communication outside of your laptop or computer is happening at this moment, right? Let's say added simple README, right? This is so I'm committing a file, right? I'm committing everything what I have currently in my staging area, right? So everything that is in yellow here in the staging changes to be committed, right? That's everything that is listed in the section changes to be committed will be included in this commit right now that I'm doing, right? -m is the message, right? Always write a message that describes what you have changed in your commit, right?
Why do not call it comment?
I don't understand the question, sorry.
No, why don't we call it a comment?
I don't know, maybe they call it a comment. Yeah. I don't, whatever, right?
I've always heard about, the comments to any comics, right?
No. This? Yeah. And there should be. What is it? Yeah, it's message, right? The commit message, that's just how it's named. You even have a possibility to add multiple -m options and they will be concatenated. Don't do this. Important thing, always issue git status before you commit so that you always know what you are committing, right? What did I wrote there? whatever, added readme, right? Oh, this has created a new chain set with this hash. So each chain set is represented by a hash, right? When I do git log now, you'll see, well, there's the initial chain set, and there is the new one, right? So this is the unique identifier of the chain set that we just did. If someone else creates even the same exact change, right? The change is the same file in exactly the same way, the identifier will be different, right? It's always a different identifier for every change, even if they are virtually the same, right? They do the same, but someone else did it from different computer. You would do it, right? It will be a different ID. So each change has a unique identifier here. So that's also for Git to be able to distinguish between different change sets, right? I will use this git hist pull maybe, right? This is from this well, properly named project, right? And this is a more verbose representation of the previous. So this is basically the same, but a different visual representation of the same, right? So it shows, this is the first, it starts from the bottom, as every tree does, right? We read it from the bottom to top, right? From the roots to the leaves, bottom, top. So what happened before is at the bottom, what happened recently is at the top, okay? So 46 minutes ago of my constant talking, I did an initial commit, and where there was nothing there, no files basically, right? And then you see my second commit here, right? And it's A for added, a new file, readme md, right? That's hopefully.
I have a question.
Yeah.
Command does work.
Did you add all the contents to your Git config from Git Curva project? So that's why it doesn't work, right? So it's an alias from this properly named project. Okay. That's what we're going to, right? So apart from all this, you can see there is a shorter version of this hash. I'll get there, okay, in a second. There is a shorter version of this hash. The interesting thing is that the initial, like, 7 digits are always unique. I mean, or usually unique. I don't know. That's usually enough to distinguish the revision. You don't have to pass the full number. So even though it's there, to identify the revision, the initial 7 characters, it's enough. So in every command that you have to pass in the identifier of the change set, it's usually enough to just pass in those 7 first characters, not the full long string, right? But apart from those types that are really nice, another interesting thing here is this, right? What's this? Origin master, master, head, origin head, right? So we were saying that we have copies of the repositories, right? So I was saying that I have a local branch master, and on the remote repository there is also a branch master, right? So what this shows, master is my local branch. So because I created a commit right now, my local master branch is currently as this change set. Right? I have added readme, but I changed only my local repository. I didn't update the remote repository yet. So the remote repository is still on the previous change set, right? So origin master tells me where the remote repository is, right? This is clear? That's where branches are, right? And every other branch will have the same thing, right? You will have the branch and origin / branch name, and this is the same branch but on your local repository or remote repository, right? Head. head is where you currently are in the repository. So I am currently here. This is the place where I am. I am on branch master. I can do git out. This, I want to go there, right? I want to see what was there, and I want Git to check out the state of the repository on this change set, right? So I issue this comment here, right? Git checkout. So it's kind of similar with SVN, right? Git checkout in SVN, if I remember correctly, was actually also checking out the state of the repository in given revision, right? Here it is the same, but we interact with local repository. Well, it wrote this big warning. Okay, sorry, you are in a detached head, so you are no longer on a branch. Actually, you have chosen a specific change set to go to, right? But we'll get there. Git status. No, I wanted to git his full, right? Oh, that's why I don't like this this thing. It's no longer showing me the everything I need. That's better maybe. So currently my head marker has moved back, right, to this change set. I specifically said I want to go back there, and now there is no README file here, right? The state of the current working directory was reverted to the state of the repository at this change set. Okay, and that's where the head points to, right? That's where you currently are, and the same origin head. That's where the remote repository is currently, right? It is set to be in this place, right? That's the head of the remote repository. It's maybe not that important where the head of the remote repository is, but it is usually on the head of branch master. So the most recent commit of master branch, that's where you will usually find the head of the remote repository as well. Okay. So to go back, I just do git checkout master, right? So I can, in git checkout command, I can pass the name of the branch I want to go to, or the specific revision change set hash, right? So I do git checkout master, and I'm back to my local branch master, right? My local copy of branch master, where it was. Okay. Everyone still following? Yeah, clear? So I have compiled the project locally. I have run all the unit tests. I am sure that the project is compiling and I didn't break anything, right? So now I'm ready to push, right? Always remember before you push, right, to compile your project, run unit tests, and make sure that things that you are sharing with your team are actually working, right? Because that's what you're doing. By pushing, you are sharing your code with your team, right? You're pushing into the remote server, and then your teammate will download the changes, and you wouldn't like them to have their local workspace crash because of your changes, right?
I have a question. I merge local connectors. For example, I made that
yes, you can. Yes, you can. Let me go through push, and I'll try to go back to that. Okay, let you remind me if I don't. Push. It's HTTPS. Okay. So because I have used HTTPS, what's my username? Okay.
conflict, I suppose that it will use my credentials because you have it as collaborator, my user in GitHub, and it doesn't work.
Well, right now I see that someone already pushed something, and I have a conflict.
I ask a question, sorry.
Yeah?
By pushing some file with question.
Thanks. So I was hoping to get there later, but we have a conflict, right? So I have tried to push my changes, and Git said, "Whoa, sorry, man. What you think is you're pushing is actually that doesn't match the remote repository." So let's see. Did it change my local Git G2? No, nothing has changed. Git just said, your local copy doesn't seem to match the remote repository anymore. You cannot push at this state. Synchronize your repositories first so that you will be able to push. To do that, issue, for example, git pull, right? So let's do just that. So git pull will synchronize the remote repository with my local copy. Okay? Cool. Okay. Now, what usually happens if someone commits before you, right before you? I mean, you have done everything already, and you just want to commit in SVN at this moment, and then you try to do it, and someone just did it right before you, right? What usually happens then in SVN when someone is a few seconds faster than you? Yeah, and then what you do with it? You did lots of changes, right? And he did lots of changes. You end up with one big merging mess, basically, at this moment already, right? Because you have lots of changes and you cannot commit them, right? Because someone did a commit there and changed, and you have to synchronize, right? Some in SVN also, right? Am I right or wrong? Or am I messing something up? Because I don't really remember SVN so well right now. Okay, so let's leave it. Let's focus what happened here. So let's see what has changed. So that's how our repository looked like before I pulled the changes, right? What do you think how it was going to look like now? Has an idea? Let's see what has changed in the remote repository. Let's go back here. Yeah, there are two commits here, right? So Patrick created one commit. So how it's going to look like? Is it going to be like the bottom one and I don't know, the two branches on two sides? Or mine first and his second? Or his first, mine second? Which variant do you think? How is it going to look like? What does it mean? Which one is the? I mean, the bottom one, of course, the initial commit stays, right? Because it was synchronized before. And now what? Which one is the next one? Mine or his? Yes. Or was he the first one, or did we? Because we both started from initial commit basically. I have created a change set based on initial commit, right? So I have created kind of one way. I mean, we are in kind of maybe not in terms of time, but in terms of our parent commit, parent change set, right? We have the same parent, right? So what you would expect actually is that you have one here, right? And then kind of it's branching out, right? His here and mine here, for example, right? Because we have one parent.
He's committed. He's pushed first, so he's the next one, and you're will be the next one.
No, that's actually not the logic that Git follows. Excuse me?
If we use a decision, up to you, which one should be the first and which one should be the second?
No. Git will actually sees those change sets like this. As I said, there is one parent that we both started from, and one of us did one change set, and the other one did the other change set. That's just how it is. That's what happened here, right? It's not, nothing else happened, right? There's no first, second. We are just in different places at the moment, right? But notice one line here.
Still on the same branch.
Yeah, still on the same branch, right? It's called split head, right? Our branch has two heads at the moment. It's like Hydra, right? Because I have a different head and Patrick has a different head. We have two heads and one parent there below, right? So by default, what Git will try to do, well, that's not a good situation where you have split head, right? That's not what you want to do. You don't want to have one head. You want to have one consistent place where your branch currently is, right? So to do that, what Git will try to do, it will try to rebase. It will try to rebase my changes. So it will try to change the parent of my changes. So it will shift from this parent right here, my changes, at the top here. The whole tree that would be here currently is just one commit, right? But the whole tree I would have here, it will try to shift here. So it will basically take all the changes that I did, right, and will try to reapply them one by one on the new head that it has downloaded from the remote repository. Does this make sense for you? So as a result, we get one line, right? The previous initial commit from Patrick, and my reapplied changes at the top. Okay? Okay.
Okay. If you say so.
You see the place of the markers has changed, right? The origin master is now on Patrick's commit, and my local master is still on my commit, but it was rebased, right? Oh, yeah. Yeah, sure. I mean, we can do a break. Just to give me, let me finish one sentence. After the push, all the markers are in one place, right? This means that we are in sync with the remote repository. Our head is where the remote head is. Our master branch is where the remote remote master branch is, right? And Git status will confirm that we're all up to date. And a coffee break. Jasne. Musisz.
Nie. Ja
Poczekaj, zapytamy się Darka, jak to zrobić po Bożemu?
A to nam powie, że tak źle robimy.
Właśnie. I może nauczymy się robić dobrze.
Nie, dajcie mi ten wodę sobie przynieść.
Jest przepad, można wykorzystać czapatynę.
Moje?
10 minut się nie zbawi. Jeśli nic jeszcze nie zrobiłeś. Normalnie, no 10 minut się nie zbawi, tak? A pod nimi boisz się, że zgubisz coś?
Nie ma jej rozwiązania.
Przecież ja chyba nie wiem. Będą gdzieś wpadać.
To jest instrukcja.
Nie, co? Nie wiem, dużo ma. Tak, dużo.
A nie, przecież to jest nie lubię.
Kołnie.
Gdzieś mi się nie wyszło. Zrobiłem. I powinien się zrobić wtedy folder home. Co? Pokaż.
Mamy takie kolorowanie.
Tak, to ja wiem. Ale
Działa, tak?
Dobra, czyli to spróbujmy jeszcze raz. Ale czekaj, to ty nie masz...
Czy to jest naprawdę?
No to możesz spróbować.
No to zobacz.
Ale to wszystko jest tego komunikowało.
A, co to było?
To nie powinien
Jest, tak.
Nie to dobra. Tyle ten 2 razy. Nie. Slash. Kropka.
Tak?
No. Nie masz takiego rzeczy.
To są to.
Cały. Tak.
To miałem już to robione.
No to znaczy nie to.
Ale jestem tu u siebie, z tym dzielam projekt, a mam to, że teraz...
Nie, to nie w kołdzie masz zrobić, a nie tam przy prawie.
No to kurczę.
Daj.
Nie, to już
Masz gdzieś...
Adresi, a merdże, nie wiem, czy na to nie, no tego. Dobra, zamiast na to wyrażasz wszystko, co nam się można. No wiesz, nie, może ten lecz są przed tym twoje? Twoje. To jest
Czym?
drugi. Tutaj po środku też, to też wszystkie twoje. Jeżeli będzie, to też jakiś...
No tutaj.
I tutaj masz... Oto. Konflikty.
Jak masz komity, musi być fajnie.
No to weź o to, to
Powinien być bezżadny. To czego ty kuszni, czy to robisz? Komity już tam są.
Możesz sobie...
Tu masz kurczę.
Ale to nie. To nie jest pula. Żeby kuszło jeść,
Ale tego sobie usera i maila.
Ale jak to się pisze?
Przystawiasz.
To weź biorę ciebie jak sztuk.
Patrz, czy związek nasz
Dźwięk
z nami.
I co, iskrzy?
Nie.
Otwórz.
On dostał z Patrykiem i z Markiem.
Ale Marek to pójdzie. No mam. Gdzie jest?
Username i e-mail. Patrz, jak się tam naprawdę.
Co ty na wsi mieszkasz?
No.
Tragedia.
A ty gdzie mieszkasz?
Nie, dlatego mogę się śmiać. Kurwa, drugi.
No właśnie, ile
No właśnie nie mam dzisiaj. Właściwie to będzie.
A ty mieszkasz?
Zależy od regionu jeszcze.
No Stachu, jak to kurwa tylko dochodzi? Przecież ty tam gdzieś na Śląsku mieszkasz.
Nie mam jakiś kształt.
Obok Bełchatowa.
Kurwa, wejdziesz na górę, to hałdę masz, no to powtórzę ci to.
Na hałdę byś skoczył.
Krzysiu, przekroczyłem barierę ciągu.
500 zł. Dobra,
Kurwa.
No czekaj chwilę, Stachu.
Jak patrzyłem ten pierwszy raz, to myślałem, że tego muzyka, tego
Nie mam.
Stachu, będziesz coś teraz protestował?
Kurwa, nie
Stachu, jesteś nasz kolega.
dwa pasy.
powinieneś się w ogóle wylogować ze Skype'a.
No. Nie nawiera tak pójdę do lewa. Znaczy było zrobić wyszczelnie offline.
Dobra, to jest jakaś pierdolona.
Uj, no i wreszcie. No i wreszcie.
Czy wygląda na przejętego?
Dobra, a co to tam
Może jest lepszy sposób.
Coś czytałem, jak Maciek Stoczyk ostatnio opowiadał. Parę rzeczy mi tam
No właśnie nie wiem po co.
skóra, czy coś mi chodziło, ale...
No właśnie nie wiem.
żeby nie było konfliktów.
Chyba tylko...
Nie, wywalamy.
Położyłem się wtedy, dodał mi koszu do GitHuba i...
To się zapytać w międzyczasie. Mamy sobie na plus w międzyczasie dostajemy od IMPAQ eksport z GITa, ale bez katalogu samego pliku. No ja wiem, że da, ale inaczej się nie da.
Na tym, no to tak,
Znaczy ja wiem, że się da. W kraju przypadku możemy robić, że same wysłać i z tego moglibyśmy otworzyć wszystko. I jak te remote, to znaczy w tym momencie nie mamy wjazdu do ich GITa. Tylko sieci. Ze względu na politykę, jakby wymieniamy się, też nie. Też nie.
Bo są
Masz security.
Ale w sensie, to, że wy do nich, to ja rozumiem, ale skoro mogą wam wysłać plik, to równie dobrze mogliby...
Przez SFTP.
To już dużo.
Wiem, w skrajnym przypadku mogliby nam się podzielić z nami tym katalogiem .git.
Nie. Skoro mogą zobaczyć i wysłać po SFTP, to czemu nie mogą zobaczyć i spuszować do remote'a?
No ale o to chodzi, że ich security officer, jakiś British Englishman powiedział, że nie, bo nie. I nikt z nim nie może dyskutować, ani my, ani oni.
Ale to jest kwestia, wysyłają wam plik,
Tak, są
tak, do podsieci, kwestia tylko techniczna, że to jest inny protokół.
Wysypają nam mailem, ale tak, nie. My też im to tłumaczymy od 3 miesięcy.
Tak, ale się nie da. I wymiana jest...
To jest bez sensu, bo wy się rozjeżdżacie historią w tym momencie, nie ma jak
No ja wiem.
merdżować.
Oczywiście, że
Znaczy, de facto nie mamy historii, mamy tylko jakieś tam punkty w czasie
No właśnie.
i tyle, tak? A to, co działo się pomiędzy, to nie
To jest
wiadomo.
bez sensu, bo tracicie jakby cały tą...
Okej. I załóżmy, że się nie da inaczej. I jak do naszego repo to wrzucić?
Nie, to...
Najlepiej.
Nie. Znaczy...
Do tej pory robię tak. Wywal odpowiednią zawartość katalogu, wrzuć pliki, git add, git commit, git push, tak? No bo ja robię tak, jak wykryć ewentualnie brak pliki, tak?
Jak szef.
Zmiana
No nie ma takiego
prosto.
problemu.
kurwa, wszyscy.
Dodanie pliku prosto, ale zniknięcie pliku jest trudno wykryć.
I tutaj
Ja to nie może się dodać. Kwestia, że to musisz zupełnie zrobić na oddzielnym branchu.
Tak jest.
Nic więcej nie zrobisz. Nie masz
Okay.
Bo de facto historia tego brancza powinna ci przychodzić z zewnątrz i powinien puszować. Tak?
Puszować albo w skrajnym przypadku wysyłać chociaż katalog.git, nie zawiera wszystko.
Puszować.
Tak?
Puszować. Kiedy jak już mogą wysłać plik, tak, to co będą zrobić push.
No mam nadzieję, że tylko nie problem się rozwiąże, że będziemy mieli w ogóle jedno wspólne repo, tak? No ale do tego czasu musimy jakoś sobie radzić. Więc usunięcie plików na dysku
Ale
to już po.
Ale w tym momencie na tym wasze repo połączenie będzie do wyrzucenia, tak?
No tak.
No tak.
Rób tak jak do tej pory. Rób tak, żeby było dobrze.
Okay, we're back. Any questions after the break to what we did already? How are we with the schedule? Let's see. They're on the schedule still. Introduction, that's what we did. Local remote repo. Merge conflict. We just well, that wasn't conflict resolution. True conflict resolution. Connection between branches, remote and local. Okay. adding, removing files. Okay. Was more than in the beginning. I think we did quite a few things already. Okay, let me know. Well, let's try true conflicts maybe. This sounds interesting, right?
Yes. We have a question from Rick about merging local commits.
Oh yeah, we do. I would have to do. So I'm doing one change. That's what I always forget. Yeah, that's what I was. That's what I said, right? Earlier, I did a change. I had it in here, and that's a common thing that I do. I try to commit when I didn't add anything to the staging area, right? So then it shows me on branch master. Okay, changes not staged to no changes added to commit. So even though I issued git commit, the commit was not created because there were no changes, right? So as you can see, there is no new commit here, right? Right now, when I have git, and when I have changed, actually added the file to the staging area, now that when I commit, the commit is created. I have created two changes, right? But I have them locally and locally only. And maybe for the changes, it's not that important. But for example, sometimes you do some changes, then you do some more and some more and some more, and in the end, after refactorings, you end up with something completely different. And sometimes it is nice to have this history, and sometimes it's just useless noise in the history tree to having that many change sets, right? That basically don't really do anything because they were reverted then, and something else was done in the end. So sometimes you would like to merge those two commits together. So this is kind of rewriting the history. And that's something I don't remember how to do. I remember what to look for. I don't remember how to do it. Okay. See what it did? Oh, okay, so I have to do like this. Cool. Not. I didn't read to the end, right? No. Something's not working as I expected.
Narek, what do you want to do? Maybe I can help.
I want to squash those two last commits together.
Dobre. Oh, in one command.
Yeah. So you want to do all the data, don't let you get one to do. Let's change. Done, save and quit. Oh, okay, now I know. Okay. Without, okay. I have broken something. It's very base abort. Okay, and let's try again. It's a combination of three commits. The first commit message is the second. Okay. Cool. That has broken things, but that's okay. I already know how to do it. Okay.
But currently I see your history also interesting situation when you have one branch like branch and one.
Yeah, that was I just learned how to do it, and now I'll hopefully will be able to pass it on to you. Sorry about that. I never really used this use case personally, so bear with me. I'm back with the repository as it was, right? Change one. By the way, git add dot is git add every changes that you have, right? Might have skipped it because previously we were saying git add and the file, right? Git add dot is to add everything that I have changed.
Is there a comment like git add minus all? Not in current.
That's dot. In current directory and subdirectories. So if you go into a subdirectory and issue git add dot, it will apply only to current directory and subdirectories. Right? You can also type patterns here, right? If you have like packages, for example, you can do git add like com, IMPAQ group, whatever, / and star at the end, use wildcards, right? And it will add all files matching the pattern only. Okay. Change. Change to. Change. Now, have this situation, and instead of 2 commits, I want to have 1 commit, right? So I want to squash together, right? Merge, but that's the last two commits into one, right? So I'm saying yeah, that's the number of the commits that you would like to change, right? So I want to operate on the last two commits. I want to change them, squash them into one, right? So I say if I wanted to change more, right? I would like write the last 3, 4, or so, right? This operates on the commits from head to back, right? The previous one, and so on. Okay.
So I should currently.
That's not the end. That's not the end. That's the beginning. I issue this command and I go into this nice editor, right? So now I say pick first change, and on top of that squash second change. So what I'm typing here is actually not comments, not messages. Those are commands. I'm typing commands for Git to do this rebase here, right? You see, I have changed pick to squash, right? The second commit that I did, I want it to be squashed and merged into the previous one, right? And then I exit, save, and this is the commit. This is the editor for the resulting change set description, right? So first change and first and second change, right? For example, right? Yes. Okay. Done. Right. So we had those two here, right? This command. The first change we have left as unchanged, pick, and the second one we changed pick to squash, right? And this created instead a new change set that has both of those changes within itself, and we created a new message for this new change set. Okay. Yeah, and we did this only on our local repository, right? You see that origin master did not change. And one important thing, never ever do this on the commits that you have already pushed. When you have pushed something, don't try to change it, right? This is public history at the moment, right? And if you try to change this, bad things will happen because others have already most likely pulled those changes to their local machine and they have a different copy and lots of conflicts will start happening, and just don't. So when you push something, that's how it stays. You can only add on top of it, right? You can do git. One more useful command is git show. For example, I would like to see what was in this change set. You can see there was this change 1, right? In this change set was change 2. And in this new change set, there are both changes, right? So you actually can see that those changes were merged into one change set, right? Okay. And someone, I don't know, change those two lines and push. right now. Let's create a conflict, for example. Anybody, please? I mean, I can do it on my own, just create a second copy, but that wouldn't be that fun. I want to see what you'll type in. Yeah, and in any point, if something breaks in your local copy of the repository and you don't know what to do, just delete it and clone it again. Okay? Okay. We have some changes in the remote repository I can merge with. I can't see them yet. Well, who is pushing? Anybody? Hmm? Well,
What was the question?
can you push some changes that will change those two lines that I have just pushed? Well, just change something in this file, whatever, in this README. And in the meantime, I'll see what's in the question. Just because. I zamknij cudzysłów na końcu.
I push something.
Yay. But not in the README. Oh no, you did.
Inside the README.
Yeah, that's interesting. I can't see this.
Can't see? Do git tip.
Oh, check. Okay, that's okay. That's fine. Yeah, that's good. Fine. Okay, so that's what we have, right? We have changed one file. We did the following changes there, right? So we changed lots of stuff, but we didn't change anything in those two lines, right? So we changed like every other line, but not those two that Patrick changed. What do you think will happen?
Conflict.
Okay, let's try it. Add first, right? Yeah. We try to push, and it fails because we have remote changes. Okay. So what has happened here? Excuse me? Yeah, exactly. So as you can see, applying added more changes and something else. So it has downloaded changes from master, and it says rewinding head to replay your work on top of it. Right? So it says exactly what it does. It goes back to the remote head, takes my changes, and tries to replay them one by one on the new head. It says, oh, modified README, and the README was modified in the remote commit as well, falling back to patching, base, and freeway merge, basically. Freeway merge is there was a parent, there is a one remote change, and my local change. So it's kind of a freeway merge, right? From one parent, I have two different branches that I'm merging. And it's trying to do it automatically. And actually succeeded at the moment, right? So it had some more input here, but it is exactly the same thing as before, just rebased my changes on the new head. Patrick, can you do changes again in those two lines?
Sure, I can.
Right. Just pull first, because I've pushed mine changes. Or in any other line, okay? Okay, there we go. Change. Okay, great. Thanks. That's what I wanted to do. Now let's do some real conflicts. I don't like this. I want to revert this. Change. Change here. Change 4. Check 4.
Darek, by the way, you could fix the typo in the last line.
To jest na szczęście, nie wiem, czy będziemy instalować na wersji testowej.
Anything else, right? And that will merge. What else we have? Change here. Check. Change. Okay, so now we both changed to the same line, right? Let me just make sure. One. Okay. Git diff, git add. More changes. Of course, never type such stupid message as I do now, okay? Describe exactly what you change and not that you have changed something.
Well, but what should I write when I can't totally remember what can I change? But I know that I changed something. Right?
You know, you have this magic command, git diff, and you know what you have changed then, right? Issue this command and it will show you what you have changed.
And when I am in a hurry.
Stop being in a hurry.
Yeah, sometimes I'm in a hurry and
no, that's in a few months you will be searching, looking for something that you did 3 months ago. You can't remember well, but you think you did it like when doing like this feature, right? This one feature. Unfortunately, you forgot to mention this feature in your command. So instead of just searching through the one phrase and having the result within 5 seconds, you are going through every change set of your 10-member team that commits 50 change sets a day. After 3 months, you're going through hundreds of change sets looking for this one thing that you were in a hurry not to describe well. Don't be in a hurry.
Yeah, I remember. I totally understand the purpose of adding comments, but you know, sometimes it happens.
No, so sometimes just don't.
Okay, I will do my best. I promise you.
So this is really that's versioning control is in versioning. It's really important to describe your changes well, right? And don't write I have changed line 57 in file this and this. That's stupid. That's something that is automatically included in the change set, right? Describe the functionality you changed, the feature you added, right? Not that you changed this file. Okay?
Comments like some refactoring, some changes.
Yeah, don't do that. Let's try to merge. Yeah, and there we have a proper conflict, right? And I mean, since I have this nice shell prompt here set up, right? You can already see the difference. In here, I was clearly on branch master. In here, on the branch, rebasing master, right? So I'm technically on master branch, but I'm in the middle of rebasing. So what Git tried to do is he tried to do exactly the same. He downloaded remote changes and started to rebase my changes on top of it. Unfortunately, he was unable to auto merge as it was done previously because he met a conflict line, right? I did a change in the same file and the same line that Patrick did, and that's something that Git can't handle on his own. It needs some help from us to tell which change at this moment is more important, or maybe both of them should be applied, right? So it does the rebase. It starts the rebase on its own, but it's stopped right in the middle. Don't worry, nothing is broken. You can continue, right? What you only need to do is to resolve the conflict and then tell Git continue. I have resolved this conflict for you. You can continue rebasing and finish it and try to finish it. And if you have any more conflicts, it will stop again and ask for your help, right? So it told me you both modified, means I modified something and someone pushed a modification of this file to the remote repository as well, right? So kind of both means that my local and the remote repository both have modified version of this file, right? You can see in this picture very well the split head situation, right? My local master branch is in one place and the remote origin master is in the other, and we are in the middle of doing the rebase, right? So there are some text-based tools for merging that I don't use. I know Patrick does, I think. I think you can use Vim or whatever to merge. I don't. What I use is configured in config that we spoke earlier. right? So you have this merge here section when you define a tool. My tool is diff merge. You do merge tool and this command here, right? So that's just something that I have configured. I have copied it from somewhere. You can Google it. I don't know, probably configure diff merge git, right? And it will tell you how to set it up. Just a few lines that you have to type in to configure this, and it's worth it. It's really worth it, because then what you do, you just issue, when you have the conflict, you just do git merge tool, and it will run this tool for every conflict that you have, one by one, and it will be easier for you to resolve the conflict. So yeah, so I just run this, right? And it starts to merge the README. Right? So we have 3 panels here: local, remote, and base. Of course, local represents my local changes, remote represents the remote changes, and the base and the middle one is basically the result. So this is the place where you type in what should be the result of the merge of those 2 changes, right? As you can see, this change was merged correctly, right? You can see it's green. This one has this red indicator, meaning that, well, there is a conflict that I was unable to resolve on my own. Tell me what to do about it. Here as well, there is a conflict that you might think it should be able to resolve, but in fact there was no new line character here in the end. So Patrick added new line character, I added a character here, and that's a bit too much, right? We did a change in one line, both of us did. And what should be the result? Should it be with a new letter and without the new line, or should it be both, or what, right? So this one we don't have to merge. This one, I don't know, I'd say I want this, for example, or I might say no, completely I want like 5 here, right, instead. And in here I say I want here like this, right? And now I just save and exit, and that's it, right? And you git status, fine, that's leftover, remove this. And now I do exactly what it tells me. All conflicts fixed. Run git rebase continue. Right? Okay. Oh. Done. Right? It has finished rebasing. It rebased my changes with a little help. That's it, basically. Right? So you can configure several tools as your merge tool. Just pick one and then use it, right? It's really quite simple in the end. And pay attention to what Git is telling you, right? Let's see, it typed everything I should do to resolve the merge, basically. Well, maybe apart from this merge tool. I can rebase skip, I can rebase abort, so when I'm in the middle and something breaks, I can always go back and try again. Right? Okay, any questions to that part? I don't know if you'll have time for disaster recovery. Oh my god. Yeah, thank you. Okay, cool. I don't want this. Those are leftovers. I never have time. Those are the things I use Git ignore for. Oh. Oh. Okay. Keep committing if you want to this repository. That's okay. What I wanted to say. Okay, we did merging. I wanted to say something. Oh yeah, Git ignore. You have this svn ignore, right? File. Hopefully you know it. You do, right? You know this rule that you commit to the source control only the sources, as it's the source control. Source, I mean, it's version control. Okay, so the version control tool, you should commit and push only the actual sources, right? Not the generated files, not the binary dependencies, not the big like Excel spreadsheets with some or some other stuff that is basically used, like I don't know for what. Just the source code, right? When you run your local build, it usually generates some compiled classes. Don't commit that to the source control, right? To avoid committing such things, you have these files that basically describe what should be ignored by the version control tool by default, right? So when I create a new file here, for example, yeah. By default, it will tell me that there is a new file, that it is untracked file, right? But I can create it in a special file. And I go in and say no, this kind of files are stupid files, and don't bother adding them to version control, right? And look at that, it ignored that file, right? Okay. Maybe like this. Sorry? Yeah, you can add folder names. A folder name will be ended with a slash, I think, if I remember correctly. What I usually have, yeah, that's what I usually have, like for Java projects, right? First thing is like all the files that start with a dot. That's an easy way for me to add some temporary files, right? I need some debug log or whatever, so I just redirect it to a file starting with a dot, and I don't have problems committing it by accident to version control, right? So it's always good to have such common pattern that you can use for temporary files, and then it's a target directory. That's where all the things are compiled in Maven or Gradle projects in Java, right? Or IntelliJ IDEA descriptors, these ORIC files, some log files, whatever. You can have several patterns or specific names. I tend to use patterns. Few well-chosen patterns should be enough for most use cases to exclude all unnecessary files in the repository. For compiled and generated files, it is useful to always keep them in one directory, or at least in a directory that is always named the same way. And that's, for Java, it's target, right? So each project has a target directory where each module has a target directory where it keeps all the generated data, and it's enough to just exclude the target directory for every module like this with one line, and I can put everything I want in target, and it won't be added to source control. Okay, so it's good to separate already at the root of your module the sources and the binary temporary files, right, or distribution files that you generate during compilation. Okay, clear? Yeah, so I have.
But sometimes we must add some binaries, for example, for external libraries.
No.
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 So
that might be a different topic, but what we do, I mean, at least in Java, we have a separate repository for binary dependencies, right? So there is a separate service for that, right? And we have dependency resolution mechanism that tells the project to download this dependency from this remote repository,
okay,
to use it to build our project, right? Okay. So no third-party libraries in binary form should be added in the repository. Right? It should be in your binary repository, your local binary repository, right? Okay, we have this gitignore. Interesting thing is let's add this pattern to for all files starting with a dot, right? So now when I issue git status, it's a shortcut to git status, git-st, okay? I have this file here. I will add this here, right? So exclude all the files starting with a dot. Funny thing, .gitignore starts with a dot, right? So we have just ignored the .gitignore file. Okay, but how do I commit it then? Because I want to have it in the repository. This is the file that you commit, right? So that everyone that downloads the repository also has these settings, right? And doesn't put crap into the source code. Well, okay, that's how we do it. -f. As you might imagine, -f means force. 3. Step ahead. And there we have it, right? Now I can commit. To be honest, that's usually the first commit I do to every repository. Right at the beginning, I add gitignore, so I'm sure that no one will put by mistake some crap that I don't want in my repository. Right? That's the first thing that you should add in your repository. Maybe apart from README or something else, but gitignore is for me the most important file that I always put. as the first one. Okay, cool. We have this. Branches. I was talking about branching is easy, right? Well, I could tell you, because branching is easy, I could just do git branch my, let's say I'm working on a new feature, right? That is called my feature, an original name, of course. I just create a branch. Check out my feature, right? Cool. Wow, our history is growing, right? So now you can see there is a in our repository there is origin master, a master branch, and also my feature branch that is actually in the very same place that master branch. And now maybe important thing to understand is a branch in Git is only a named pointer to a change set. That's it. Actually, nothing more, right? It's just a name that you put. It's a kind of a label that you put to a change set. So you can basically move around this label wherever you want. Just remembering that things that you have pushed are public history and you shouldn't change it, right? So we can move it around as long as you don't push it, right? Because then you technically still can, but you shouldn't do it because you will break the others' copies, right? So right now this branch has no representation in the remote repository, right? So there is no origin, my feature. So how do we change that? Just git push, and since I'm pushing this branch the first time, the remote repository doesn't really know what to do with it. It has no representation on the other side, so I have to say, what was that? Set upstream, and the upstream, so the remote branch, it's good when it's named the same as the local one. So we just repeat here. Okay, set upstream in origin. That's the syntax. Okay. So can you see this? Hopefully you still can see this. So we are pushing a new branch. So we're telling that in the remote, which is called origin by default, this branch that we are currently pushing will be also named my feature. Right? That's what it says. Set upstream, origin, name of the branch. Right? So in the remote origin, because in Git you can have more than one remote if you don't know by now. That's why they have names. Right? And then you can say that you're pushing to this remote and or to the other. You can, for example, push directly to your colleague that is sitting next to you, if you so desire, instead of pushing to the remote. But that's not what you usually do. Then maybe you can read about it if you would really would like to do it. But you can have multiple remotes. If you remember, we did. I don't remember the comment, but what you do is just add a remote, and that's it. Another shortcut that I use is minus O as upstream origin my feature, right? So it's the same, minus minus set upstream or minus U. Yeah, and it said branch my feature set to track upstream my feature from origin by rebasing whatever LG2, and now you see there is origin my feature and my feature here, so we have those branches linked at the moment, right? To remove a branch locally, that's important, that's easy. One thing, you cannot be on the branch currently that you would like to remove, so I have to go back to master checkout master. CO is alias for checkout, right? Okay, and I can see I have the following branches, so just git branch -d and the name of the branch. So there is a small d and capital D, and it's delete. Both of them is delete. You can delete with small d until you, as long as all the changes that are in your branch are also in some other branch. So meaning that when you did some changes and you merge them back to another branch, that's fine, right? Because those changes are already included somewhere else. But if you did some changes, right, and your branch has its own, let's do this maybe. Git branch no. Let's create a new one. Even different. It's my new feature, right? Yeah, let's no. Readme new feature. Cool. Right? I did some changes on this branch, right? And it is only on this branch currently, right? I don't have a remote branch, but it doesn't matter. When I go back to Git master and I try to -d my new feature, okay, error. The branch my new feature is not fully merged. If you are sure you want to delete it, run git branch -D, right? So capital D is like kind of a bit forced delete. Remove the branch even though it has changes that are nowhere else. So Git can detect it, right? It can see that there is a branch, you did some changes there, and they are nowhere else. You didn't merge them back. Sometimes you want to drop those changes, but it will warn you, right? So when I use capital D, it didn't delete it. I have to use capital D to actually delete it in this case. And then it was deleted, right? And it's gone. Just cut off the branch. We also deleted this my feature, but remote representation lingers on, right? We have to remember we have a separate repository locally and separate remotely. And this is where things get a little bit strange, at least for me, at least at the beginning, because you might think that removing a remote branch will have at least something of a command that would tell you like delete, remove, like -d is delete, right? That's okay. But actually to remove the remote branch, it's git push origin by feature. That's the syntax of the command to remove a remote branch. I asked someone who knows a bit more about Git. It's like push. This semicolon actually is a separator. It says push to origin, nothing in place of my feature. Right? That's the kind of logic behind this command. It will tell you deleted my feature. Following still, everyone? That's just something you need to kind of remember, right? Okay. Yeah, and the rest is the same. You just commit to the branch, right? And maybe let's try to merge it back, right? So git branch my new feature, git checkout new feature, and no readme new my new feature. Cool. And one thing also to remember is that you can have local branches, right? You don't have to push every branch to the remote. You can keep local branches on your repository until you feel ready. That, I mean, sometimes you can keep them local and just merge them back to the main branch, right? And don't push your local branch at all. Just keep it local. What we do in the project, we push them for code review mainly purposes, right? So we do the changes, we push it, and it's the changes are waiting on the feature branch until they are reviewed. Actually, the QA review also happens on the feature branch, and only after code review and QA review, the feature branch is approved to be merged back to the main branch, right? And that's the only reason to share it, right? That's why we push it. You can do code review locally, right? Just go to your colleague, right, with the laptop, or ask him to come to you and just do the code review, and you can merge it, right? You don't have to push it. So the procedure is exactly the same, right? Whether you push it or not, it makes no difference. You merge it exactly the same way. When you push it, though, you have to, apart from removing your local copy, you have just need to remember to remove the remote representation, remote pointer as well, right? So I have this. Okay, git. So now I have, let's say, git push -u origin my new feature. Let's push this as an example, right? So now I have this locally and then I have this remotely. Let's say the code is reviewed. I'm going back to master. Okay, as I'm moving around, keep notice for this head pointer, right? You see, when I was on this feature branch earlier, my head was here, right? When I moved back to master, my head goes back here. So always look for heads to know where you are in the tree. And I just do git merge and I will do this maybe strange flag here. There are two approaches to merging in Git. The default approach that Git tries to apply is rebase. So when you are trying to merge, it's like the same when you are pulling the changes, right? And someone else did changes, and the first thing that Git is trying to do, rebase, right? That's not always a good idea, especially if you have pushed your branch to the remote repository. Git will not mind this basically and will try to rebase anyway. At this very situation, it might not be the worst solution, because I can say that basically there are no other feature branches and no new commits on master basically, right? Just my feature branch is based on master and it has new commit. So I could just move master one commit forward, right? And that will be fine, right? I will just rewind the master. That's okay. It's like changes are in master now. Master is there. But I like to keep the history of my branches clear. Some people don't. Some people like to have one just line. But for me, it's better when I know that this feature was implemented on this. These changes were done in this feature branch. These changes were done on this feature branch. And I want to have a clear view where the branch started and where it was finished and merged back into the main branch, right? So that's why I say no fast forward. I don't want any rewinding. I want actual merge to happen. So I want to have a merge commit. So I'm on master, and I want to master merge another branch. It's always this way, right? You are moving to checking out the branch you want to merge into, and then you say what you would like to merge into current branch that you're on. I'm on master, and I want to merge in my new feature branch. It's just like this. It will show me what changed. And after that, I can see explicitly that this one change set was done on the side, right? I went to some feature branch, did some changes there, and then I have merged it back into master, right? And I can just push this now, this merge, and you will see that origin master has moved up here. Well, now my branch is useless, basically, because all the changes I have already merged into master branch, so it's no longer needed. So I'm just removing it. I can use small d, right? Because even though I did changes, they are now merged into another branch, so this will work. Right? Delete it, no problem. And of course this to remove the remote. And I'm back with origin master, but now I have this funny thing here, right? That tells me, yeah, there was something done on the side, not in the main branch. Yeah, and here you will notice actually Dominica's commits. So that's something that Windows tools do by default. When I was doing git pull, right, the default behavior was to rebase my local changes. As they were not pushed yet, it is safe to rebase. It's a change of history, in fact, right? Because you are previously this commit was started from one parent, and now you are changing this because it is rebased to a new parent. But this is local history, and it is safe to change. And this is actually a good behavior in this situation, to rebase your local changes if you can before you push them, right? So that you don't create these merge commits when they are not really necessary and don't bring anything new. Dominika is using some tool that is basically creating, instead of rebasing, by default it is merging. And that's why we have this merge branch master of HTTPS here, right? That's Dominika doing a git pull in a situation when she did some local commit and someone else did a commit on the remote repository, and with her local tool, instead of rebasing, created a merge commit. Okay.
Impressive.
So try to use the tool that doesn't merge here but rebases instead, or configure your tool that you're using to rebase instead, right? It's better to when you want to avoid rebasing, you can always use this minus -ff. Okay, we are technically at the end, but I wanted to say a few words still about a tool called Git-flow. Does anyone know what Git-flow is? No. Okay. Some people on the other side might know, but still I would like to say a few words. So we have these branches, we can create them easily, merge them easily. As I said, conflict resolution is not that hard. Git can figure out lots of merging on its own, and that's really good. But it can be okay. Every tool you have to know how to use well to be efficient with it, right? When branching is easy, it is also easy to end up with a situation that you have a lot of branches and you're starting losing control what is where, which way it was merged or not, and what's going on actually, because you have everyone is committing to a different branch and what's going on, right? So there was this smart guy once and published a nice article. It's called A Successful Git Branching Model. Right? When you Google for Git-flow, that's the article that you will find, and that's the beginning of this tool. Git-flow is basically a convention. Actually, it's not even a tool. It's a convention that you use for naming, merging, and basically handling your branches. Right? So you have this master branch here. It's like this. This is the image that tells everything. And you have the master branch. This is your default branch. And one interesting thing, you never commit to master, ever. Nothing. This is your main branch, and you never commit there a thing. Nothing gets committed there, except for merges. You only merge into master, never do regular commits. Okay? This is your production. This is your production code. Right? So the branch that you do your regular development, it's called, by no surprise, develop, right? From development. That's where you do commits. But also don't do big commits to develop. That's what branches are for, right? So in develop, you just commit small fixes, right? Bug fix, typo fix, right? This kind of stuff, right? Something that is really small and like you removed some commented code, right? This doesn't change things much, right? So use this for this small kind of changes. When you have a task that requires several hours or even days, create a feature branch. And where to start this feature branch from? Start it from develop, right? As here, those yellow dots is develop, right? These pink ones are feature branches, right? So you start a task in Jira, right? And you create a feature branch. The very good practice is to put the issue number in the branch name. Then it's easier to find, right? Then when you have a list of branches, it's automatically also the list of issues in Jira which those branches implement, right? And another practice that we use, we put our initials in the name of the branch, so we know who is responsible for this branch. So that's because like every 2 weeks we get a release and there is this list of branches and this and this and this. Oh my God, who should I ask about those branches, right? Now I have to go to Jira, ask who was working on this issue, and so on and so on. No, I just have a list. You there, right? Should this branch be merged to release or not? What to do with it? So this is the practice that we use. So we use feature / Jira issue number / initials / the actual name of the branch, right? You can see this probably here. Yeah, You have feature, issue, initials, and the name, and so on and so on. Use feature branches for that. And when you are finished, you can do, as we do, you can do code reviews, you can do QA review on feature branches, actually, right? You can always merge develop into feature branch, but only merge feature branch back to develop when it's finished, right? So when the feature is actually done, it was reviewed, it was approved, right, that it's done, merge it back to develop, okay? And this way you can implement, add new stuff, right? Small things you can add to develop directly, but bigger stuff go through feature branches. Okay, then the day comes and you have to deliver the package to production, right? Well, a few days earlier, actually, you should prepare this package, right? So you look at your repository, you have this develop, you have this master, and now what to do? Okay, so in SVN there was this code freeze, right? No one, don't commit to repository, we are releasing, don't touch, because it will break, right? Only fixes, don't touch. So in Git, what you do? Okay, you say, okay, this looks okay-ish. Let's try to stabilize this version and release it, right? So what you do? You create a release branch, right? So everyone keep committing to develop, whatever. I don't care. This will not be included into release because I have created a release branch, and I will only commit small fixes into release branch that will stabilize the release, right, and fix critical errors that cannot go to production in this release into release branch. Never ever commit like new features and big changes into release branch. That's not the purpose of this branch. This is only for stabilization and preparation of the release, right? So you can see it's the same as feature branch, but it's different purpose, right? And when it's ready, right, you create a tag, right? Yeah, that's the version I have deployed to production on this release branch. You create a tag and merge it back to develop and merge it to master. This way you say, okay, this was delivered to production, bah, master, and this way you have always a place in your repository where you can go and see this is the code running on production. So when you get the production bug report, you just check out master and look up the exact line from the stack trace that you get from in production, right? You have always this place where you can go for that. There's one more scenario. It's called hotfix, right? Sometimes you don't want to deliver new features to production, but you want to just fix a very big bug that slipped through QAs and somehow got to production, and you need to do it really fast. So what you do then is you create a branch, a hotfix branch starting from master. So you're starting from your production code, the one that was deployed, create a hotfix branch, put this fix into the hotfix branch, deploy this to production, right? Tag it and merge it to both master and develop, right? And this strategy basically handles all scenarios that happen during working on a software project and maintaining it. When you will follow those rules, you should have really no problems preparing a version to be deployed, stabilizing it, and not holding the deployment over the time where the version is stabilized, right? Because you can commit to develop, whatever, I don't care. So you can always remember several things. You can always merge develop into a feature branch. Actually, it's a good practice to, before you pass a feature branch to QA review, merge develop into a feature branch so that all changes that happened in develop from the time that you have started your feature branch up until now are included in your feature branch as well. so that you are testing your changes on top of all the changes that everyone else did already, right? So that you don't test your changes in separation, because when you create a branch, you separate, right, from the main development branch. So try to test always not in isolation, but in integrated with all with changes that others already did. So you can always merge develop into your feature branch, never the other way around. Feature branch gets merged to develop only once, and then it's deleted, right? A bit differently, you handle release branch. You create a release branch, and you can always merge from release to develop, never the other way around, because develop contains new features that you don't want to include in the release, right? But release can contain fixes that you do to stabilize the application that you would like to be included in develop as well, so the other developers that are working on the application already can use this fix as well and don't create their own instead, right? So develop to feature, not back. Release to develop, not the other way around, right? Hotfix also. You can always merge hotfix to develop, no problem, right? Because you will do it anyway when you finish the hotfix, right? And never commit to master. Only release and hotfix or hotfix can be merged to master, and when they do, they are removed. They are merged also to develop, both ways, always, to two places, and then removed. I encourage you to go through this article, and there is Git-flow at this page. So let me add maybe this things to read. And this is a nice visualization of Git-flow. A cheat sheet that tells you the basic things. It's for Mac or whatever, but Linux, Windows, on Cygwin, Git-flow init, feature start. Oh, one more thing that I forgot to. There is this F11 info. Yeah, there's actually an extension to Git itself that adds extra commands that support Git-flow, right? Because you can of course create those branches yourself, feature branches, release branches, and so on. But there are tools that make this easier. So first thing you do when you want to use Git-flow, apart from git init, you do Git-flow init. This, well, I already did it here, so maybe we can do it. New repo, git init, and initialize new repository, and Git-flow init. And then it will ask you, which is your production branch? By convention, it's the master. Which is your development branch, where you prepare the next release? By convention, that's develop. What is your feature branch prefix, right? So how would you like to distinguish your feature branches? Git-flow uses prefixes in the names simply to do that, right? So that's by convention a feature. Your release branches prefix, it's release, and your hotfix branches, it's hotfix. Support, that's actually not really used maybe much. That's an experimental feature. We don't use it personally. We tried support branch, but it didn't work out. It's in fact not needed. And version tag prefix, if you would like to have any prefix in your version tag, we don't. That's just how it is. And that's it. You're done. It will create right from the bat two branches, master and develop. And what you have to do is just add a remote and push master, push develop, and then you switch to develop and start the whole Git-flow process, right? To start a new feature branch is Git-flow feature start my new feature, right? And what it actually did, it created, because we set up a prefix, it created a branch called feature / my new feature, right? So what I would actually do is I would do Git-flow feature start ABC 1, 2, 3, my Jira issue, my initials, new, awesome, and the description of the feature itself, right? That's what I will usually do, right, as a naming convention. And now I have this branch created, and I just commit there and do all the stuff that I need to do. And when I'm done, I do Git-flow feature finish and the name of the feature, starting without the prefix. So in Git-flow commands, I omit the prefix. If I would use raw Git commands, I would have to use the prefix. So when I'm git checkout develop, when I want to go back to my feature, I actually have to type feature and the full name. But when I use Git-flow commands, I omit the prefix always, whether it's feature, release, or hotfix. Doesn't matter. I refer to the branches without the prefix in Git-flow commands. Only in raw Git commands, I put the full branch name. So where was it? I have Git feature start, and when I'm done, I do Git feature finish. To publish the feature, so it was Git to publish the branch to the remote repository. There is also a shortcut, Git-flow feature publish, right? So this will do this Git push origin, Git push -u origin and the name of the branch, right? And you can pull the feature, or you can just check out the just pull the remote and just switch the branch. To make a release, it's very similar. Git-flow release start instead of Git-flow feature start. And yeah, this is optional. So what we do is we don't have release branches, but we have a hotfix branch, for example, active right now, right? So we have, for example, release / and the number of version that we are releasing, right? So we say this is the release / version 2.8.0, right? Releases always have 0 in the end. Hotfixes will have the next numbers after the last release in the end, right? Also release finish. See, and release finish will do both merges. It will first merge to master, and that it will merge to develop. So with one command, you will have 2 merges done. And the branch will be removed from your local repository as well within this command. If the tag doesn't already exist, it will also create a tag. We didn't speak about tags, but that's maybe not that important in your daily work, or useful actually for releases mainly. In practice, it's not much different than a branch. It's just a label that you attach to a change set. You just can't do this merging and stuff on tags. It actually needs to be named branch to do proper merging and operations, right? So we just tag a change set that, yeah, this is the code that we deployed to production in this version, right? So it will have when you go here, you will hopefully see some tag. Not so long ago. Yeah, there is a tag. This is a tag from release, our recent release, right, to production version 2.8.0. And I can always go there. That's what was released back then. Right, so in master I have the most recent release, and tags tell me about all the releases that I did previously. So if I have like several customers and each of them has a different version of the application, with tags I can easily go back to that place in the code and see the exact line from the stack trace and match it well with the actual source code, right? Because the tag gives me this possibility. And hotfixes, actually also finishing hotfix does 2 merges at once. So this is a nice cheat sheet if you forget the comments, how to. Git-flow, init, feature, release, hotfix, start, finish, publish, pull, and the name. The road is going down. One more I think that I wanted to say is we didn't do disaster recovery, but I think I will skip that simply for today. But I wanted to let you know about one more thing still before about Git-flow. Add here, and one more useful extension to Git is called Git'em. I Git'em because Git pull. What Git pull does, it works on your current branch. So, for example, Git develop, Git replace on master. Okay, Git push minus o develop, origin develop, Git commit. Okay. Broken. Let me show you one thing, one that you might encounter when working with Git pull. SSH. You would expect, I mean, when you have to remember that when you are pulling the current branch. So the pull works only on the branch that you have currently checked out. So it will actually synchronize the whole repository with, so all the branches will be, remote branches will be reflected in your local repository, but it will rewind only the branch that you are currently on. So if there are new change sets in this branch that you currently are at in the remote repository, it will be moved to match those change sets, right? Your local pointer will be moved there also. But if there are changes in another branch, the changes will be pulled and the origin pointer will be in the correct place, but your local pointer will remain where it was. It will not be moved. So you will have to check out this other branch and issue git pull on this other branch as well, so it gets synchronized, right? And if you have many branches, you might imagine that's not what you would like to do constantly, right? Also, one more thing is you have this remote references, right? What git pull does is git pull only creates them. So when remote branches are created, the Git pool creates in your local repository a kind of a representation of where the remote repository is, right, on this branch, right, this origin develop, origin master, right? That's okay. That's good, actually, because it will always show you not only where your local copy is, but also where the remote copy of this branch is currently. But when the remote branch gets deleted, Git pool will not delete your local pointer that technically should point to the same place where the remote branch is, right? So let's imagine you have a feature branch, right? And the feature, someone else deletes this feature branch, but you have once pulled this feature branch, right? And you will still see this origin feature pointer in your repository until you manually remove it, right? Which is misleading because this feature doesn't exist anymore in the remote repository, right? It was there. It will point to the last location known to you of this feature branch, but it will not longer exist. So to both update all feature branches and remove those obsolete references, there is an extension called Git up, basically. I personally use a Python port of this, and when I issue Git up, it will go through all my feature branches. I have all of them, check if anything changed, it will update them, it will forward them, it will rewind them, right? And go back to the branch that I was previously, right? Let's see if something changed. We can type it. Yeah, and this, it will stashing, I forgot about stashing. It will stash my changes, go through all the branches. It said it detected that I have that many local branches. It said it's up to date with remote, up to date. This one doesn't exist, and that's this is not the remote pointer. This is my local branch. So I once checked out this branch, and I have a local branch that I set to track a remote branch, but the remote branch no longer exists, so that's why the error. You have a local branch that is set to track a remote branch that no longer exists, right? So this way I'm notified. You can safely remove this branch that you have locally because it no longer exists on the remote, unless you need to do something about it. So I recommend this as well. So useful stuff. This one, and where is this? This. Yeah. Okay. Okay, will do. So I recommend using those two things also, and I think I'm over the time already quite a bit, so any questions? And tell me if I should do a follow-up with disaster recovery or something.
I know I sit in the office, so I
I have a question, Derek.
Yeah.
But I have a question about merging.
Okay.
Basically, I would like to know if you have a situation that you want to extract and change the file that has been merged already to another branch. For example, you have a branch A, you merge this branch to the branch B, and then after some time there are some other commits coming, and you want to come back to this merge, and you want to modify file from this branch. I mean, in this merge, from this merge commit. First, you have to identify it, and then to modify it. How to do that?
I mean, you technically can.
You have a couple of files, and you don't know what files. So first, you need to identify. You know there is a problem with this merge, and you want to come back to this one, and then modify some, do some change there on this merge.
I don't know if I will be able to do it like from the top of my head. One thing is that if it's pushed, don't change it, right? Because it's public history, and don't change commits that you have already pushed. If it's not pushed, well, you can. I don't remember now from the top of my head, but in general, you use git log with appropriate switches to find things in history, and you can really find a lot with this command. You can search for specific file history. Even if it was removed, you can still search for the history of specific file, and it will go through and show you in which change set it was changed. Then you can see what actually was changed with git show on given file, what was changed in this file. It's like the same as we did, like git show. For example, I don't know, this one. I can do minus stats, right? And it will tell me that readme was changed. I can do this, and this will only tell me what was changed in this revision in this file only, right? If there were any others, they would not be shown here.
Okay, but Darek, when you do, let's say git show on the commit, if you do the same on the merge, you cannot see the file that is inside this merge. So git show will work with the commit, but only when you.
It depends if the merge introduced any changes. If there was a merge.
No, but if there are some changes. Let's say there are a couple of files changed. Git show won't show you the file name first. So you have to identify this one and how to do this one. If you have merge commit, because if you do a normal commit, then no problem.
I don't think you should. I don't think you should think about it as modifying a specific commit. First, you need to find the commit that caused the error, right? And it doesn't have to be a merge commit.
But sometimes you would like to know the history, right? What has changed inside this merge, and that's my question basically. And then if you go and use git log -3, git show, it doesn't show you the files that you have
if the merge commit itself changed anything, that must have been the case that there were conflicts, and the conflicts introduced changes. If there is nothing visible in the merge commit, it means that this commit did not change anything. In fact, it's only a merge commit. Changes were done in previous commits in different branch. So you shouldn't look for anything in this commit because it didn't change anything.
Okay. I think I will have to show you some real example.
Probably so. I think it's a bit too complex to speak about in theory. Anything else? Okay.
Yeah, I have one question here. Can you show, for example, or explain how to fix something called split head branch?
We had a split head when we had a conflict. Remember?
Okay.
You just rebase in this case, right? Rebase or remove, both work.
But rebase from where? From the branch which is correct, or it's broken?
It's not like you have stuff broken. Split head appears when you have changes coming from one place and changes coming from the other place. And you need to
mostly it appears when you are merging branch and forgot, for example, to push, and meantime someone else pushing something. Yeah.
Yeah, so that's the scenario that we went through. If you go to the video and go to the part merging, I showed that there at one point, right?
Okay, yeah, okay, great.
there was a split set, and the regular merging mechanism that is automatically run by Git here will just handle this without problem.
Okay, thanks.
Okay, anything else?
I have a question. Okay, one more. You know, for example, if you have such situation that you push something to the remote, is it possible to roll back those commits? Because I know it's possible. Because
yes, it is possible. You shouldn't do it.
Yeah, I know, but the question is not should or not should, but how to do it.
So let's say I have my master currently on this change set, right? And I want to move it back. As never move master. Don't do that. But let's theoretically say I want to roll back something that I pushed, right? So in other words, I want to move the pointer of my remote branch to some new location, right? So first I need to identify the location where I want to go. Let's say I want to go here, right? So I do git push origin, location, and the name of the branch. So you remember this deleting of branch, right? There was nothing on the left side of the semicolon. Now there is revision number you would like to go to, right? And this is something you should not do. You see, forced update. Yeah. You see, the remote branch master is now here. So in practice, you have rolled back the commits that were after this commit on the remote repository. Don't do it.
Okay.
For local commits, that's different. That's totally different. You do git reset, and depending if you'd like to keep the changes or not, if you'd like to keep the changes, you'll use soft mode. If you want to drop the changes, you use hard mode and just change set, right? And this will move my local pointer. And my local develop. It moves the local, the current site. So local develop was moved now here because I am on develop, right?
Yes, but sometimes you can use also git revert, you know, in order to have history in your commits. It's I think better than reset.
History rewriting is maybe a whole separate chapter that we might do on Git of the different techniques of rewriting history. You shouldn't do it usually, right? It's only in specific cases that you would need it, and try to first grasp properly Git-flow, how it works, regular feature branches, release branches, the whole thing, right? Just if you have this under control, you can find anything you need in the Git history, you're good, and then you can build on that with some advanced options. Okay.
Okay, one more question. If you, for example, if someone, for example, delete the branch from the remote, and accidentally also from local host, and then this history is still in remote. So I understand you can use git reflog and then to restore this.
Yeah, that's the disaster recovery part that I don't have time ready to make.
That's why I'm asking the question.
Next time, okay? Because now we are over time by half an hour, and I think everyone wants to go home already. Okay, so if there will be, if you would like to, drop me an email, and in some time I can do like more advanced stuff. If you have any problems, send me them, and then I can make a list of specific cases. I mean, of course, I will help you directly, but then I can make a list of cases that you have problems with, and maybe create a workshop from these cases, right? Okay. Okay. Thanks very much for participating. See you on the next workshop.
Okay, thank you. Bye bye.
Thank you. Bye bye.